Hello and welcome back to Jules Math Tools, where math is made easy. In our session today, we are calculating the HCF, or the highest common factor, using the division ladder. And in this session, we're going to be using two numbers with one division ladder. You want to see how this is done? Let's get started. In our example today, we will be calculating the HCF of two numbers 30 and 48, and we will be using one division ladder for this question. Now, in a previous video when I did the division ladder with two numbers, I told you that in some cases when working out our prime factorization, there are going to be cases or there are going to be situations where we're working through the question and we may have to focus on prime factorizing one number and then continuing on with the other one afterwards. So we're going to see that in play in this question. But as you work through the question, remember that with our division ladder, we use prime numbers only. We do not use remainders. That's a no-no. Remember that there are no remainders in the division ladder. Either the number divides out completely or you find another prime number to divide by. So remember, the division ladder, we use only prime numbers. We do not have remainders or should not be getting remainders. And that you make sure that as you divide, all of your quotients are lined up correctly under the number that you divided into. Okay, so let's get started. So I'm going to begin by looking for a prime number that I can divide both 30 and 48 by. Now, you may decide to use a different number. Now with prime factorization, I guess I have to state this first before we dive into working out this question. It's almost similar to working with the factor tree. Remember that with the factor tree, we can break a number up into different parts or with a different factors. And even though we may use different factors to start our question with, ultimately, as long as we work out the question correctly, we should still arrive with the same prime factors. And the division ladder is no different. So regardless of which prime number you decide to begin with, at the end of your question, we should still have the exact same prime factors for our working. Okay, so let's begin. So since 30 and 48 has a common prime factor in 2, or you can say 3, whichever one you decide to begin with, remember that it doesn't matter which one you choose to begin with, the answer should still be the same. So I'm going to begin with 3, I guess, since 3. So I want to begin with 3 since 3 is the larger number. So 3 will divide into 30 10 times. I notice that I'm putting my 10 underneath the 30 because that's the number that it divided. That's the quotient for that question or for that number. And 3 will divide into 48 16 times. So now that I have 10 and 16, I'm going to look for a prime number that I can divide into both or maybe just one at a time. But since 10 and 16 are both even numbers, I know that both of them can be divided by 2 without a remainder. So 2 will divide into 10 5 times. 2 will divide into 16 8 times. Now since I'm already dividing by 2, I'm going to continue dividing by 2 for this part of my question. Because I know that with 5 being a prime number, the only factors that 5 have is 1 and itself. But with 8 is a composite number, so it has more than one factors. But because 8 and 5 does not have any common factors, I only can divide into one of them at a time. And since I'm already dividing by 2, I'm going to continue dividing with my 2. So that means that with my 5, it will remain untouched or unchanged, and I will just simply move the 5 down in my division ladder. So remember that when you are working out 2 or more numbers in the division ladder, if you do not divide into the number, you do not change the number, or you do not write it as a remainder. Again, I have to stress that. Just simply bring the number down in the division ladder. And we're going to continue doing that with 5 until we begin dividing into 5 again. So 2 will divide into 8 4 times. And again, since I'm already dividing with 2, I will continue with my 2. Which means that my 5 will once again go untouched. So I will bring the 5 down in the division ladder. And I will divide 2 into 4 twice. Continuing on my division with my number 2, since I'm not completed as yet and I can still use 2 again. 5 will also once again go untouched or undivided into, so my 5 will come down in the division ladder, and I will now divide 2 into 2, which will go once. And since my second column is now completely prime factorized, I'm going to shift my focus back to my 5. So I need a prime number that I can divide 5 by, which is of course 5. So 5 divides into 5 once. And since my second column is already completely prime factorized, I will bring that one down as well. Okay, so we just prime factorized 30 and 48. So now we have to calculate our HCF. And in calculating your HCF for 30 and 48, remember that for this example, we did use multiple numbers. But remember, just as I stated in the previous video, when you are looking for your HCF or calculating the HCF, remember that you're looking for the number on the division ladder where your prime factor divided into both or all of the numbers at the exact same time. That means that one number would have divided into both of these numbers at the exact same time. So I'm going to go through my division ladder and check all of my prime factors. So let's start with 3. In our division ladder, 3 divided into 30 and both 48. So I will circle this 3. In my second line, 2 divided into both 10 and 16. So I will circle this 2. On my third line, 2 did not divide into 5, but it did divide into 8. So I will not circle this 2 since the 5 was not divided into. On my fourth line, once again, the 2 did not divide into the 5, but it did divide into the 4, and since it only divided into one number, I will not be using this 2 as well. In my fifth line, once again, the 2 only divided into the 2 but not into the 5, so this number 2 will also remain untouched. And in my last line, my 5 divided only into the 5 but not into the 1 since it was already prime factorized, so this 5 will also not be used in calculating my HCF. So because only the 3 and the 2 was used, we will be multiplying 3 times 2, which will equal to 6. So my HCF for 30 and 48 is 6. Okay, so I hope this video was very helpful to you. I hope you were able to calculate the HCF even if you had a little bit of fumble along the way. But remember that with practice, you will get better. So we will see you again in the next video right here on Jules Math Tools, where we make math easy.